All right, let's get started. Once again, thank you so much for joining today's webinar on AIoT driving business efficiency and innovation. I am Mohit Paryani, working as technical lead at Decos, and I'll be guiding you through today's session. Before we dive in, let's take a quick look at today's agenda. We will begin by understanding what AIoT actually means and why it's becoming essential in healthcare. Then we will explore how data, which is at core of AIoT, needs to be managed, integrated, and secured. Next, we will discuss infrastructure needs, regulatory responsibilities, and the importance of compliance. We will also look at how to address challenges around security and interoperability. Finally, we will wrap up with a view of what's coming next, including emerging technologies like digital twins, ambient sensing, and personalized care systems. This roadmap will help you think ahead and make informed decisions for your own organization. Let's start with basics. What is AIoT? AIoT stands for Artificial Intelligence of Things. It's the merging of two powerful technologies, IoT, which gathers real-world data through sensors and devices, and AI, which processes that data to uncover insights, make predictions, and even automate decisions. Here is a simple analogy. Think of IoT as the body senses like eyes and ears collecting information, and AI as the brain, analyzing that input and making decisions. For example, in a smart warehouse, temperature and humidity sensors collect environment data. AI can then determine if those levels might damage stored goods and trigger cooling systems automatically without any human input. What makes AIoT valuable is not just automation, but intelligent automation. The system learns patterns over time and adjusts, making it more adaptive and responsive. Also, AIoT doesn't always need complex hardware. Even small, simple sensors can become powerful tools when paired with right AI models. This is the foundation on which we will build everything else today. The idea that connected intelligence lead to better business outcomes. So now that we understand what AIoT is, let's look at why it matters for your business. The key benefit is proactivity. AIoT systems enable continuous monitoring, meaning you are no longer waiting for reports, breakdowns, or complaints to react. You get real-time alerts and predictions from before problem occurs. This has huge impact across industries. For example, in logistics, AIoT can reroute shipments based on weather and traffic in real time. In utilities, it can predict demand and prevent overloads. Second, AIoT reduces manual overhead. Route tasks like data logging, inspections, or adjustments can handle automatically, freeing up your teams to focus on strategy and innovation. Third, it allows personalized experiences. AIoT tailors action based on specific users or environments. Imagine a smart office where lighting and adjust based on who enters the room and the time of day. No switches needed. Ultimately, AIoT gives business three key advantages: faster decision making, improved efficiency, and the ability to scale without proportionally increasing manpower. When business adopt AIoT, the benefits are both immediate and long-term. First, AIoT enables early detection of operational issues like failing motor, rising power consumption, or a customer complaint trend, so that action can be taken before it escalates. Second, this leads to higher uptime and optimized maintenance. Instead of fixed schedules or reactive service calls, maintenance can be scheduled only when needed, saving time and reducing cost. AIoT also improves resource utilization, whether it's electricity, space, inventory, or manpower. You use only what's needed and when it's needed. In customer-facing industries, AIoT enables personalization. For instance, retailers use it to adjust product displays or promotions dynamically based on foot traffic or behavior. Combined, these factors leads to cost saving, better customer experience, and measurable ROI. Let's pause for a quick poll. Among the use cases we discussed, which one seems most valuable to you in your setting? Remote monitoring, predictive alerts, diagnostics, workflow automation. Thank you for participating in poll. I see that each of you have your own perspective for approaching AIoT. Strategy and circumstances will determine the right approach for you. AIoT needs strong technical backbone for to function properly. Edge computing allows critical decisions to be made locally, closer to the devices, which reduces latency and doesn't rely on internet speed. Cloud platforms like AWS, Azure, or GCP are ideal for heavy analytics, historical pattern learning, and AI model training. They offer flexibility and scale. Then we have network infrastructure, 5G, fiber optics, or Wi Fi mesh, which keeps everything connected and in sync. In short, AIoT is not just plug and play. The smarter your system, the more you must plan for connectivity, power, bandwidth, and uptime. For example, in healthcare, a delayed alert can mean the difference between intervention and escalation. This is where edge computing comes vital. Even more, real time decisions often need models that are lightweight and optimized for embedded environments. Balancing what stays on the edge versus what moves to the cloud is strategic decision that shapes the success of your deployment. Let's take a deeper look into the infrastructure that supports AIoT beyond the basics. Firstly, power resilience is crucial. AIoT systems run 24/7, so backup power sources, failovers, and redundancy planning are critical. On the edge, real time decisions often need real time operating systems for reliable execution, particularly in safety critical applications like healthcare or industrial automation. For data storage, you might choose between data lake for unstructured sensor heavy input or a data warehouse for structured query optimized data. Lastly, operationalizing AI model needs DevOps pipelines for frequent updates, monitoring, and performance training. CI/CD for AI is vital for managing model drift and scalability. Infrastructure isn't just about wires and bandwidths, it's about end to end system design that is robust, agile, and future proof. These slides illustrate a typical AIoT architecture. Data flows from IoT devices to an edge gateway where it can be filtered, processed, or temporarily stored. Relevant data is then sent to cloud AI models for deeper analysis, like forecasting or pattern detection. Insights are visualized in central dashboard that allows staff to take action, or in many cases, the system responds automatically. The feedback loop is important. It helps the system learn from actions taken and adjust its models in real time. These setups allow for speed, scalability, and adaptability, all key traits of a responsive business system. AIoT system must respect legal and ethical boundaries. Regulations like GDPR in Europe, CCPA in California, or DPDP in India place strict rules on what data can be collected, how it is stored, and who can access it. In some sectors, even the devices themselves need to be certified for safety, accuracy, or interoperability. Then there is a requirement of an explainable AI, which means AI decision must be transparent and auditable. If an AI recommends shutting down a line or adjusting pricing, your staff and regulators need to understand why. This isn't just a legal requirement, it also builds trust with your teams and customers. Ethics is more than compliance. It's about doing the right thing that data and technology. Bias in training data can lead to unfair decisions. If your model is trained on narrow or unbalanced dataset, it could favor or penalize certain groups unfairly. Consent must be explicit and ongoing, but not buried in fine print. Users should know when and how their data is being used by AI. Finally, accessibility matters. AIoT should not just benefit the privileged few, it must be designed to work across diverse regions, devices, and skill levels. The more inclusive your system is, the more valuable and accepted it will be. For example, a smart assistant trained predominantly on English language datasets may misinterpret speech from non native speakers, affecting everything from customer service to diagnostic tools. AIoT brings great power but also new vulnerabilities. Many IoT devices run on outdated or insecure firmware. If not patched, they become open doors for hackers. Networks connecting devices are potential attack surfaces. Malware or spoofing attacks can take control of critical systems or steal sensitive data. MIM attacks interpret data in transit and alter it without detection, potentially causing major disruptions. In AIoT, every new connection is potential risk. So we must design systems with security first thinking. Here is how we keep AIoT systems safe. Start with end-to-end encryption so that data stays private and protected across its entire journey. Ensures devices use secure root processes and strong authentication. So rogue devices can't join your network. Use network segmentation to isolate critical systems. So a breach in one area doesn't affect the entire organization. Lastly, adopt a zero trust model where no user or device is trusted by default. Everything must be verified continuously. Security should be built in, not bolted on later. Let's take a quick poll to understand your perspective. In your experience, what is the most significant challenge when it's come to implementing AIoT systems? Data privacy and compliance, high infrastructure cost, lack of skilled workforce, integration with legacy systems. Thank you for participating in poll. Depending on the field or situation where you are implementing, each of these challenges can be greater than the other. For example, in healthcare, data privacy and compliance is paramount. A digital twin is a virtual model of physical object, process, or system updated in real time. Think of it as a test lab where you can simulate different conditions, predict failures, and optimize decisions before applying them in the real world. Factories use it to model production lines. Cities use it to manage utilities and traffic. Buildings use it to plan HVAC and lighting. Digital twins save cost, improve reliability, and reduce risk. They are a great next step for mature AIoT systems. To deepen our understanding of digital twins, let's explore how they are implemented. There are three common types: product twins, process twins, system twins. Product twins for individual equipment or devices, process twins for workflows or manufacturing lines, system twins for entire ecosystems like hospital or power grid. These twins rely on multi source data from IoT devices, historical ERP logs, to 3D models. The twins remains live synced with its real world counterpart through continuous updates. This enables predictive maintenance where you can simulate failure points in advance. You can also run what if simulations to test changes before implementing them physically. And in training, especially for healthcare or industrial roles, digital twins serve a realistic, risk free simulators. In short, they transform insight into foresight and guesswork into precision. Digital twins also enables cross-functional alignment. For instance, Operations can simulate maintenance windows. IT can test data systems. And finance can model cost impacts, all using same tool. This breaks silos and allows for better, faster decisions. AIoT can deliver hyper personalized experiences. A retail system might adjust promotions for each shopper, a factory might adjust lighting or machinery speed based on who's working that shift. Even customer support can become smarter, prioritizing urgent issues, suggesting next steps, or routing the right person based on life context. Personalization is also is Personalization is no longer just a marketing gimmick. It's becoming an operational standard powered by real-time AIoT feedback loops. Ambient sensing is about gathering insights without interfering. Instead of cameras or wearables, you use pressure mats, vibration monitors, or microphones to detect activity and changes. This is especially useful in environments like offices, warehouses, or elder care, where privacy and comfort matter. Ambient sensors paired with AI help system make context-aware decisions, like turning off lights, detecting faults, or identifying distress signals silently. It's subtle but powerful. Let's now walk through a real-world AIoT case study in logistics and warehouse automation, an industry where timing, accuracy, and efficiency are critical. In this deployment, a large warehouse integrated IoT shelf sensors, pallet trackers, and edge-based computer vision cameras to continuously monitor item placement, storage capacity, and material movement. These systems were synced with warehouse management system and enterprise resource planning software, forming a connected ecosystem. The AI layer added intelligence, detecting anomalies like misplaced inventory or insufficient routes, forecasting restocking needs, optimizing internal transport, all in real time. As a result, the company experienced noticeable improvements in inventory accuracy, faster fulfillment cycles, and reducing logistics costs due to more efficient use of space and optimized routing. Let's explore a compiling case study from a multi-specialty hospital that deployed AIoT for post-surgical recovery monitoring, a critical period where complications can arise unexpectedly. The hospital equipped patients with wearable health monitors tracking heart rate, oxygen saturation, and skin temperature. In parallel, smart bed sensor detected whether the patient had moved recently or maintained health sleep posture. These IoT devices stream data to an AI engine which continuously evaluated early signs of immobility related risk, example bed sores, post surgical fever or irregular vitals, and changes suggesting dehydration or infection. The AI didn't just alert nurses, it also recommended specific interventions such as encouraging movement or administering fluids. The outcomes were nurses were able to respond more promptly, post operative complications became less frequent, and patients reported feeling more secure and well supported during recovery, leading to smoother discharges. This case demonstrates how AIoT improves not only clinical efficiency but also patients' outcomes in a measurable way. Let me share an example from the world of long term care, especially how AIoT is transforming chronic disease management outside the hospital. A home health provider deployed wearable IoT devices and AI dashboards to support patients dealing with chronic illness such as diabetes and hypertension. Daily vitals like blood glucose levels, blood pressure, heart rate, and skin temperature were automatically captured using smart patches and glucometers. These devices synced seamlessly to a cloud platform without requiring the patient to do anything manually. Once the data was uploaded, AI engines continuously analyze it for irregularities. Instead of waiting for crisis to occur, the system would proactively alert care coordinators. It could suggest adjustment to medication, trigger a telehealth appointment, or simply recommend increased hydration or rest, all based on live context. The results were meaningful. Patients experienced fewer hospitalizations thanks to early intervention. Medical adherence improved as reminders and context aware nudges were integrated into the system. But more importantly, patients and their families felt safer and more supported, knowing there were always a intelligent system keeping watch even between doctor visits. Managing chronic conditions is a long-term game. It requires consistency, awareness, and timely action. What AIoT does in turn, the passive what AIoT does is turn the passive patient into a active participant, not by adding effort, but by removing the burden of manual tracking. This kind of proactive loop not only improves clinical outcomes, it reduces healthcare costs, eases the burden on hospitals, and build confidence in patients managing their own health journey from home. To summarize, AIoT is transforming how business work from reactive to proactive, from manual to intelligent. To succeed, you need more than sensors and software. You need good data, good governance, and ethical guardrails. Start small, build a strong foundation, and scale up strategically. The future isn't just digital, it's intelligent, adaptive, and connected. AIoT is how we get there. With this slide, we have covered all agenda points. Before we wrap up, I would like to briefly mention about the services we offer. We are a strong player in software service and healthcare industry for last 25 years. We have delivered significant projects for various clients across globe in the field of new product development and legacy devices. At Decos, we don't just develop products. We bring ideas to life, ensure they are built to last in today's dynamic and highly regulated markets. Whether you need to create something from scratch, enhance an existing solution, or navigate complex compliance landscapes, we have you covered. Our services are end-to-end product deployment, customer software and firmware development, hardware and mechanical design, software verification and validation, system engineering and risk management, regulatory and quality compliance, QMS documentation, implementation and training, product security gap assessment, sustaining engineering including remediation, and many more. All right, that is it for all today. I hope this webinar gave you great insights about business, driving efficiency and innovation in AIoT. We would be more happy to help you with your any of your product designs, development, prototyping, optimizing, and troubleshooting. We use cutting edge techniques and tools for our work. Please note, a recorded version of this webinar will be available on our website within a week. We will also send you an email with the link on your registered email ID to access this webinar. And once again, I would like to thank you all for your time. Have a great day ahead.